All right, my friends, let's see how it went. So if we're using angle B as reference, then you would look at the right triangle that angle B is part of, and then apply the sine function to that. So the sine of angle B is equal to the opposite over the hypotenuse. And then similarly, the sine of angle C, using that one for reference, we would just do opposite, which would be h, and then over hypotenuse for that one as well. So what we're working on here is the beginning of the derivation of what's called the law of sines, which is a way to solve for side lengths in a triangle, even if it's not a right triangle. So notice that these two expressions that we have here, they both have the letter h in common. So what we're going to do is isolate h in both situations. So we are going to, for example, on the first equation, multiply both sides, by c. And then we would have h isolated, and we'd know that h is equivalent to c. Try to make sure that looks lowercase there, and then times sine of angle B. And similarly, on the equation here on the right side, we could multiply both sides by b, and we would find out that h, the height of that triangle there, is equal to b times sine of angle C. There you go. And since h represents the same quantity, both h's in both of these equations represent the height of that triangle, I hope it makes sense that you could use substitution and replace h right there with b times sine of c. And so we would then have that b times sine of angle C, try to make that look uppercase, is the same as lowercase c times sine of angle B. And they could have published the law of sines to look exactly like this, but it would be a little bit harder to remember. So what they did was they just algebraically manipulated this to have the C stuff together and the B stuff together, and it made it easier to remember. So to do that in one step, you could just divide both sides by BC. There we go. And then you have this cute little equation. So sine of angle C over side length C is exactly the same as the sine of angle B over side length B. And then we could go through this process all over again, just dropping a different altitude. And we could tie in the last little piece here, which would be sine of angle A over side length A. There we go. And this, my friends, is the law of sines. And we're just going to practice using this little guy in different situations, just to solve different triangle situations where we don't have right triangles. So take a moment and try to commit that one to memory. Should be fairly easy. And then we'll see if you can apply it to example 1. So example 1, part A, the directions say solve each triangle. Remember, uppercase means an angle measure, lowercase means a side length, and angle A would be opposite side length A, etc. for B and C. So with that said, just go ahead and see if you can solve this triangle. That means solve for all the missing angle measures and all the missing side lengths. So you'd have 2 more angle measures to find and 2 more side lengths. See how it goes? Check in with me in the next video. Good luck.